Alright, today we have a physics question, and the question says a particle of mass 50 kg rotates around a rigid body with a velocity of 5 meter per second. If the radius between the particle and the body is 10 centimeter, calculate the centripetal force. Now, we know that the formula for calculating centripetal force is F equals to mv square all over r. That is force, which is centripetal force, is equals to mass times velocity square all over radius. So we write down the formula. Now, we are looking for the centripetal force F, and it is given by the formula F equals mv square all over r. The value of our m is 50 kg. The value of our v equals 5 meter per second, and the value of our radius is 10 centimeter. But one thing you have to recall is that when solving problems like this, the radius, which is the distance, should always be in meter and not in centimeter. So we have to convert 10 centimeter radius to meter radius. To do that, we divide 10 centimeter by 100. So if you divide 10 centimeter by 100, you have 0.1 meter. 0.1 meter. So this becomes our original radius that we use for inside the equation. Now let's substitute. What is our mass? Our mass is 50 kilogram. What is our velocity? Velocity is 5 meters. Now, this is velocity square, so we write 5 raised to the power of 2. What is our radius? We've converted our radius to meter, and we had 0.1 meter. So in place of radius, we put 0.1. So from here, we have that F is equals to 50 times 5 raised to the power of 2 all over 0.1. But recall that 5 raised to the power of 2 is the same thing as 5 times 5, which is 25. So we'll have something like this. I told you that 5 raised to the power of 2 is 5 times 5. 5 times 5 is 25. That's why we have 25 here. Now if you do 50 times 25, you will have 1250. Now, if you divide 1250 by 0.1, the answer will become 12,500. And what is the value of F? F is N. So it means it will be 12,500 N, which is Newton. So add N here. So it means that our centripetal force from this equation is equals to 12,500 Newton. And I hope you understand.